Hey, what up, you guys? This is Ryan with Brainstorm. So, roots and irrational numbers, they're kind of like, you learn some of this in like the 6th grade. So, but you don't really understand why you know it. So the square root of 16, for example, is 4, and you could just bark that out. I mean, if I said, what's the square root of 9, right, you would just say 3. So you've had these memorized, but I don't think, I would make the case that a lot of people don't even really know why they're getting the right answer. And what's really going on is this root symbol right here. You can have a square root, you can have a cube root, you can have a 4th root, right, a 5th root. And what's weird is for the square root, it's so common that they just stopped writing it, but secretly there's a little 2 right here. And so again, no one ever writes it, and so we don't really know it exists. And the reason the 2 is there, or the cube root, the 3, or the 4, or the 5, is that's how many times something has to be multiplied by itself to get out of jail. All right, and let me kind of explain what that means, the whole get out of jail concept. So look back at this 16. If you actually took this 16 and broke it down, right? We're going to factor this 16. You would have 4 times 4. And then if you broke it down further, you would have 2 times 2. This is down to all its factors, 2 and 2. And you always circle your dead ends, right? Okay, well, these are done. These are maxed out. What that means is, if I rewrote this, I would actually have square root of 2 times 2 times 2 times 2, which makes sense, right? Then, remember, this secretly has a little 2 up here. I'm not going to, well, okay, I'll write it. But so it has a little 2. And what that means is, you have to have pairs of numbers for them to get out of jail. Do you see any pairs? Here's a pair here. So he gets to come out of jail. So I'll write him over here, right? Here's another pair. So he comes out of jail, and they're multiplied. Whoever gets out of jail is multiplied by each other. So the answer is 4. Again, you just memorize that 4 times 4 is 16. This is really easy. But you're going to need this whole concept of getting out of jail to solve more complex ones, right? So here's an example of one that might be a little more complex, right? So what if someone asks you, what's a square root of 12? And you're thinking back from 6th grade. You're like, that's not 3 times 3. That's not 4 times. There is no square root of 12, right? So that would be your answer. There's no square root of 12. And if you put it in a calculator, you get like some funky decimal. So here's how you do it. So this is this kind of next level of roots and irrational numbers. You would factor this out just like we did. This is 4 times 3. Circle a dead end because 3 can't be factored anymore. And this is 2 times 2, right? And we're going to, as we get a little better at this, we're going to stop rewriting them in the roots. But now I can write 2 times 2 times 3. And so the root of 12 is the same as the root of 2 times 2 times 3. Do you see any pairs that can come out of jail? These guys are a pair, so they escape from jail. But unfortunately, this loner dude right here doesn't have a partner. He's not a pair, so he has to stay in jail. So the simplified version of root 12 would actually be 2 root 3. That's why you have to know this concept of finding pairs. And obviously, if you add cube root of something, like, cube root of some huge number, you'd be looking for triplets. If you had a 4th root, you'd be looking for quadruplets or whatever. So let me give you an example. But before we move on, there's one thing you should know too about fractions, which kind of makes sense. And I really just want to show you that fractions are no different, but the one thing that is cool about a root of fraction is you can look at this and kind of ask yourself what times itself would be 1/4. That's too hard. You can distribute this root to top and bottom and rewrite it. So this is actually can be rewritten as root 1 over root 4 and treat them as completely separate problems, right? Now you can only look at the top for a while, figure it out, and then only look at the bottom. The root of 1 is 1, and I'll spare you the whole factoring thing because you guys are too good at it at this point. We know that the square root of 4 is obviously 2, so we'll write that. So that's the way to do it. I think it's too hard to kind of do it in your head. Just break it apart, all right? And let's do one more. So what if you had, I don't know, root 9 over 16? I would break it apart entirely and say, well, that's root 9 over root 16. And then you can either do the long factoring version, or you can just, hey, these ones I know in my head. Root 9 is 3 over root 16 is 4. So that's what happens when you have the square root of a fraction. It's no big deal. So let's move on to, like, what if these aren't 2? Again, I don't have numbers here, so we discuss, or numbers here, these are all square roots. What happens if we have cube root or 4th root, right? Okay, so here's the cube root of 8. And again, I don't know. Don't try to do this in your head. Let's break this down. So we have 4 times 2. We're just factoring this 8. Circle a dead end. And then I have 2 times 2. Circle a dead end. Circle the dead ends. I could write cube root of 2 times 2 times 2, but I think you're kind of getting a little more advanced. So now let's just look for triplets here rather than having to put them back in the root. Do you see, of your dead ends, of your circles, do you see a triplet? I totally do. There's a triplet of 2's. They come out of jail. Is there anybody stuck in jail? Are there any loners? The 4 and the 8 don't count because they were factored out. So of our circled dead end values, are there any loners? No. So that's your answer. What if we add, like, let's maybe take it a step further, right? Maybe we'll do one that doesn't come out exactly perfectly and see what happens. So, okay, I can factor this. And the good news about factoring is I can go 6 and 4, I can go 12 and 2, whatever you know. I'll do 6 and 4. This is 2 and 2. I'm going to circle my dead ends. And this is 3 and 2, circle my dead ends. Okay, so now that I have all these factors, I'm looking for triplets, and so this is kind of weird. Okay, I totally see a triplet here. So these guys come out of jail, right? This 3 does not have 2 more friends. There's no triplet of 3s, so he stays in jail. And one thing that's a heads up that you cannot mess up, but you probably will, no offense, is when you do this, you have to remember, if this was a cube root problem, you have to write your cube root again in your answer, and then that would be it. Okay, all right, let's try another one of these suckers. Okay, well, what about the 4th root of 32? Now I'm not looking for triplets, I'm not looking for pairs, I'm looking for groups of 4, right? Well, quadruplets? I don't know what they're called. All right, so this is not too stressful. I can't do that in my head. That's impossible, so let's factor this. 32, I guess I could do 2 and 16. He's a dead end. 2 and 8, he's dead end. 2 and 4, and we'll just whittle it down until we're totally done. Okay, now, once we're totally factored and we have our circle dead ends, we're looking for groups of 4. 1, 2, 3, 4, 5. These guys make a group of 4, so they come out of jail, and unfortunately for this dude, he has to stay in the tank because he doesn't have 3 buddies, he doesn't make a perfect quadruplet. And you notice I wrote my 4th root on that, so that is my correct answer. So that's how you do those. There's one thing that's weird about these. This is all cool, you guys get this, like no more lecture necessary. There's one thing that is weird about roots and irrational numbers, and I'll explain it right now. Okay, so it's this idea of what happens if somebody asks you to root a negative value, right? Square root of -4, cube root of -8. So the weird thing is there is no square root of -4, right? Because think about it. Give me the square root of -4. What times itself would be -4? Well, it's not 2, because 2 times 2 is 4. It's not even -2, because -2 times -2 is +4. So you simply cannot, which is weird, you cannot get the root of a negative. However, confusingly, well, what about this? This one you can. Cube root of -8. That would be -2, right? That's a 2. Times -2 times -2. Negative times a negative is a positive, times a -2 is a -8. So here's the rule. Ready? This is the rule that can kind of dictate whether or not you can root a negative. All right, and here's my sort of ghetto way to explain it, but this makes sense. If you have an even number of the root, you can never even number root a negative value. So for example, square root or 4th root or 6th root or 8 or 10 or 12. If this number is even, it is impossible to find the root of a negative. So the answer is always no solution. Okay. Over here, if this is odd, 3, 5, 7, 9, you totally can root a negative, and that's okay. And so don't worry about answers, but just if you say yes or no, to the following questions, I just want to know, can you find the root or not to these? And again, don't worry about what the root is, because I totally made these numbers up in the last millisecond, so they're not going to come out even. But just the concept alone, this is an even root of a negative, right? Can you even root? Can you 4th root a negative? So this is a no, you cannot. Okay, over here I have an odd root of a negative, and don't worry about the answer, but can I get an odd, a 5th root of a negative? Totally fine. Yes, that works. Here, it doesn't say 2, but there's a 2. That's even. You can never even root a negative, so that's a falsified. 8th root is an even number. You can never even root a negative, so no chance. Odd, totally fine. You can odd root a negative, and then again, odd, negative, that's fine. So that's it. Hopefully you get that concept, and if you didn't, you could experimentally come up with the same concept, because no number times itself 4 times could come out negative, as an example. So that's the whole speech about roots and irrational numbers. Hopefully you guys understand that, and good luck in this section.